Hi guys, Mr. Bennett here again. Today we're going to be looking at some different examples of time of flight, and I'm going to go through a question with you. So the different sort of questions that you're going to get will exist sort of like this example here. Number A, if you're going ground to ground, then when we're looking at our starting point to our finishing point, you can see that it's 0. Alright, so when you put that into the SV formula, no matter what the equation might be, that's always going to be 0. So in other words, you've got your initial velocity and you've got your half of gravity. So what you can do to solve this one here is bring out a common factor. Alright, so you bring out a common factor, you can work out that the time of flight is either 0 or t equals, say, 2 in this particular case. Alright, so that's one example of how you find the time of flight. Part B is if you're going from a ground to above ground or a ground to below ground, what happens here is you're going to have some sort of value there, alright, and that means that the only way you're going to be able to solve this is to rearrange that into a quadratic and solve in your graphics calculator. Right, so that's that example there. From a ground to, change of height, really, that's what we're looking at there. Example C is when you're going from above ground to the ground, but you're going horizontally. So in this particular case, when you're doing these type of questions, you'll find that your vertical velocity is always 0, so that term always goes out. In other words, we're always then going to cross out our negative velocities, our negative things, our negative signs. And it's always going to work out to be the height that you're going from divided by 4.9, which is a half of gravity. You're going to work out the square root. So that's that particular case scenario. And then the last one, well, that's actually it. Sorry. So what I'd like to now do is go through a slightly different example where you're going horizontally, and this is question 18. So what we've got here is a car's driving off a 100 metres cliff. Right, we don't know what the horizontal velocity is, but we know it lands 40 metres from the base of the cliff. Alright, so assuming a cliff is vertical. So in this particular case, we're still going to use our SV formula. So we know that the vertical velocity is in fact 0, so that's going to go out, that term's going to go out. And with terms of, we know that the vertical displacement is in fact 100. So it's going to go down 100. And we know gravity is there minus 4.9, half of gravity. So our negatives are going to cancel out, and that's going to leave us with, in fact, 100 divided by 4.9, the square root, which is going to give us a time of 4.5 seconds. The second part of this question, so that was easy. We can use our vertical concept, the value of gravity, to work that out. If we want to work out how far it's going to go, how fast it was going, well, we know how far it's gone. So SH, we know, was in fact 40. We know the time taken for it to hit the ground was 4.5 seconds. So when we rearrange that question over here, we can see that the velocity is going to be 40 divided by 4.5, which is 8.9 metres per second. Alright? Now, the third part of this question is to find the actual speed of the car when it hits the ground. Right, so that's no different from a normal sort of question. So we know it's now going 8.9 metres per second horizontally. We know we need to work out the final vertical velocity. Now, initial vertical velocity is 0. We know it's going to be in the air for 4.5 seconds, going at gravity of 9.8. So it's going to give us a vertical velocity of negative 44.1. So to work out the velocity, we have to use Pythag, put in our horizontal velocity, put in our vertical velocity, and that works out to be 45 metres per second. And again, we have to work out the angle. It's asking for velocity, so it's going to be the vertical velocity divided by the horizontal velocity. And so that works out to be roughly 79 degrees below the horizontal when it hits the ground. So there is another example of a case where you're going from a horizontal velocity to hitting the ground. I think I'll leave that video here and we'll have a go at question 11 in the next one.